Hi everyone, welcome to the class of Petroleum Production Engineering 2, and we have already covered this lecture in the class, but in order to review the lecture I'm going to upload a video lecture on this also. So in this lecture we will talk about basically three things. Okay, and the first thing here is about the uncertainty issues, like what are the possible uncertainties are involved in the designing of this production system, and once we have designed, how we can optimize it and what are these environmental impacts that we have. So we are going to discuss the uncertainty, we are going to discuss the management optimization, and we are going to discuss the environmental impact it has. First of all, let's go ahead with the uncertainty involved in this case. Okay, now remember, first what we are doing here, we are doing the contrast. Okay, remember, here we are talking about this oil and gas field, oil field, and when we are talking about the refineries here, refinery there. Now in this refineries, the feed raw feed material, okay, let me write feed material or input is well defined, or I can write here feed material or input is well defined. It means that we know what kind of crude oil composition we are. Means crude oil composition is defined. So now once the crude oil composition is defined, you can set up your refinery based on this composition. Based on this composition, you can define. Okay. So this is, but the plants are more complex. Okay. It has the the knockout drums. It has the stripper tower, and it has so many activities. So the plant itself is complex, but composition is certain. Okay, and it stays unchanged. The plant specs stays unchanged throughout the life. This is the condition of refinery. But in this case, in oil field case, composition may change over time. Very uncertain. Because for example, today we are producing 10,000 barrels of oil. Maybe after 1 year pressure declines, it becomes 8,000. Or maybe there was any fault or fold, the gas pocket comes in or water production level raises. So we don't know. The composition may change over time. It's quite uncertain. Okay, but process is simple. I mean, what we do, we have the gas well, we have the oil well. Okay, it goes through oil well, Christmas tree or Xmas tree. From the Xmas tree via pipeline to separator. Okay, this is the process. So it's simple, not complicated like this. But designing this oil well, okay, designing this Xmas tree, these pipelines and these separate, these four sections are very complicated. 1, 2, 3, 4, because the composition is changing over time, and if the composition changes, means the situation of these four may change also. For example, let's talk about the separator. Okay, you put the separator, when you start producing the well, you were expecting that the oil production will be more, there will be no water production and no gas production. So basically you put the separator, small separator, two-phase separator here, two-phase separator. Okay, you were not expecting too much water, but after 2 years water increased. Now if the water production increased, this separator is not going to, you have to change it, because maybe, or the gas production increased, because this separator may not be able to handle this water or gas. So it's quite uncertain here in this case. Likewise, if you go for the other issues, that in the Christmas trees you are putting the, if we have, let's say this is our well, and as you know that we put the production tubing inside, and this tubing inside is It's closed here also. If I make the good drawing, let me try it again. We have the well. This is the tubing string inside, and these are the our packers. Okay, now size of this tubing. Size of this tubing. Also, maybe today you are expecting so much oil, but after 2 years, maybe the gas pocket comes in, or gas or water production increases. So maybe the tubing size that you are designing here may not work after 1 or 2 years. Again, it's a quite uncertainty involved here. So we have to have the full understanding of the reservoir. Okay, and we have to look at the initial state of the reservoir and our ability to predict what is coming after 1 or 2 years. So as a production engineer, you need to predict what do you expect after 1 or 2 years. This is one of your jobs. So production engineer has to predict also what could be expected in coming years. So he plans for them accordingly when he do the capital investment. So he plans for them accordingly. Let's look at further what are the equipments. Now, for example, this is one thing that there is a lot of uncertainty, but on the other side, you cannot put extra equipments uh, initially, okay, especially in offshore environment, because they need space and they need lots of money. So you cannot put lots of, so you have to be very accurate. You cannot put too much equipment and you cannot put very less equipment. So you have to be properly manage this uh, the production side and keep a balance between too less or too more the equipments and designing accordingly so that it can run for long time in this case. So what are the typical uncertainties that can happen? Typical uncertainty. Well, first of all, the compositional fluid, the condition at the wellhead. Okay, there could be more gas could be found, or previously we were expecting there's more oil, but with oil there's a lot of gas coming. So you have to change now the separator, the pipeline, and so on. So you have to change the wellhead completion, as I said, tubing and so on, and the pressures. So this change in fluid composition has a large effect on the wellhead equipments, flow lines also, separator also, and also you need to seal it. If you don't have facility to process this gas, you have to flare it up. If you don't have a facility to process this gas, otherwise you have to maybe inject back inside the reservoir. So you need to look at what could be coming in the next year. Second thing, the production. Okay, total field production. For example, your production initially was coming like 10,000 barrels per day. Then suddenly your production start declining. Okay, or your production was coming 10,000 per day. Suddenly you drill more well and now the production is increasing, and then suddenly start declining. So there are 2-3 phases of the production, and the facility you are designing, for example, the size of the separator, size of the pipelines, and the equipment that you are installing, they should not be too large or they should not be too small at the same time. You have to really calculate your plant facilities and equipment there before you put them, because you have to invest the money for the one time, and maybe if you oversize the equipment or undersize the equipment, maybe there could be a problem coming ahead for you. Then the third example of uncertainty is the oil and gas production rates may decrease and water production may increase. Okay, and for example, if you don't know what to do with this water production increases. Now what to do with this water? You cannot leave it in an open atmosphere. So we have to predict how much water is expected coming, and fluid changes. I mean, how rapidly the fluids are changing, how much gas is increasing. So if the water is coming too much, then you have to look at the reservoir separators, you have to look at the plant separators, you have to look at the pipelines completion and so on. And after the separator, you have to put this water somewhere, or if the extra gas is coming, you have to put them somewhere in this case. Now look at this dissolved case. I mean, how complicated it is. Dissolved gas one. Initial conditions, the we have the oil, okay, as you see here, and the gas is dissolved in it. The gas is inside. Okay, and you can see here with time when we start producing, this one. Yes, in the dissolved gas drive, as you see that the gas oil ratio, the amount of gas dissolved stays constant till the bubble point. After the bubble point, this gas comes out and form a separate phase. Okay, form the separate, so the gas oil ratio starts to decline. At the same time, the pressure is declining, but after the bubble point, it becomes a bit stable, but it's very much reduced. So based on the drive mechanism, the behavior of gas production, behavior of oil production in this one is totally different than if you look at in this the gas cap drive. In the gas cap drive, you see till the bubble point, okay, the gas oil ratio is declining, but after the bubble point, it starts increasing. And look at this, the gas breakthrough. So in this one, gas is putting the pressure on this oil, and you can see here the pressure. So when you design your production facility, okay, you have to look at the drive mechanism. You have to look at the drive mechanism. What kind of drive mechanism you have? You have water drive, or you have gas cap drive, or you have the dissolved gas drive. In all cases, you have to design your plant based on the drive mechanism you are dealing with. If you predict the drive mechanism properly, then you can design your facilities. Otherwise, situation may change over time, and the production you have designed may get stuck up over time. And look at this water one. Now, for example, one of the reasons that I'm saying that you need to look at the drive mechanism, because whether are you dealing with the water drive or the gas cap drive. If you are dealing with water drive, it means the water production will come in the coming time. If you are dealing with the gas cap drive, it means the gas production will increase. So designing the plant for the gas cap drive is totally different than water drive, because in this case you have to manage the water production. In this case, you have to manage the gas production. So both cases are different. In this case, pressure is not going to decline too much. So pressure is quite maintained, but water production may increase over time. So this depends in this case. So the plan you design for this one is totally then different than this one. And this one will have a very different plan. So you have to be careful for the plant that you design, and you have to look at the drive mechanism or drive mechanism. So when you go in any oil field or gas field, first thing you need to understand and ask them what drive mechanism you're dealing with. Because once you understand the drive mechanism, then you can look at the plant and see what they are doing there at their plant. And well, remember one thing I always say: the reservoir is always right. Okay, and the real world reservoir is not that simple as we draw here, like a picture like this one, for example, picture like this one and this one. No, it's not that simple here. The real reservoir, they are quite heterogeneous, and they're quite heterogeneous. They are not homogeneous, and they could have high permeability. They could have very low permeability. The early water can come, like as you see in general in Kurdistan region, or early gas may come here. On the other side, the reservoir may be compartmentalized. What do you mean by the compartmentalized? For example, if we have the reservoir like this one, so we divide the reservoir into these regions. Okay, for example, here now we have 4 regions: 1, 2, 3, 4. In all those 4 regions, the porosity here may be 0.2. Porosity here may be 0.25. Porosity here may be 0.10. Porosity here may be 0.18. So you see that we have same reservoir, but we have porosity different. So what we do now, we divide according to their porosity into the different compartments or pieces. So this compartment has 0.2, this one has 0.25. So maybe then you need to put the separate wells in all of those compartments. So you put separate wells here, 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 and here. And also you need to look at it, maybe there is a chance of rapid pressure drop. So in this case, you have to plan for artificial lift on time. Or maybe if you have a very strong water drive, and later on there is no much strong water drive and pressure decline, then you have to inject the water. So you have to put the place to water injection, put the place for water injection plant, and so on. So the real world is quite unexpected, uncertain, and you have to be very careful for production designing. These are the typical rate changes. For example, if you are dealing with oil, okay, the early stage you can get 100k, for example. Midlife also 100k. When it gets mature, from 100 it declines to 30k. Okay, it's also 100 to 30k. And water production you see here in midlife also increases. So initially you have very less water barrels per day, but after some time it's become 30k, and after some time it was 100k. So water cut is increasing. This is very critical to look at it. So when you design your facility, initially you don't have water, but if you design the facility without this water cut percentage, I mean, you will royally fill the production field, and your company will ask you why you did such a mess in such a and by not putting the water storage facility or water handling procedures and the separators that you put. So you have to careful water cut production. This is the production constraint how we start in oil production. As you can see that we have number of scenarios. We have number one, then we have the appraisal well. Okay, this is the builder well where we start to build up the production. Then we put do all the drilling and we make the production to the max. Then we have another decline phase. So and then we have the abandonment phase. So basically this phase you can divide into four regions: build up, plateau, decline, abandonment. Uh, four main parts you can divide the production. So when you are designing the production, you need to design basically of this region. Okay, and because this will give you the highest level of production, and your plant facility design separator should handle this kind of production rate here. And then you have to decline. When it declines, the water production will increase or gas production will increase. So you have to handle this also. And when you abandon, you just close it. During the build up we do lots of drilling at the same time. So but this phase 2 and phase 3 you have to be very careful, because this your production facility should have enough capacity to process this oil, and when it declines your process facility should be enough capable to handle the water or gas production at the same time. So these are the constraints. What are the possible constraints in during the build up, plateau and decline and so on. So in the build up, what we want to produce the maximum oil as soon as possible. So we are limited with the number of wells production. This is the proper possible constraint in this case. In the plateau, we reaches maximum level of production but remains constant. And maybe one factor could be, our facilities pipelines may be smaller and they cannot handle the production. And we we need some extra wells to put the maximum production. We have to maintain the production. We have to make sure that water level should not be increased. And in the decline phase, you have to manage the water production or gas production, or maybe we have to look for the workover operation, recompletion, stimulation, artificial lift, and so on. In the abandonment, we just close the well and remove all the facilities. So again, the plateau where we drill more wells, and the decline where we look for workover, recompletion, because we want to manage the production, are important in this case. Okay, now we will talk. This was about uncertainty. Now we talk about the optimization. How we can optimize this. Okay, how we can optimize the production operation, and what are the parameters that we can optimize it. Okay, as a production engineer, our objective is to maximize the return of investment by maximizing oil production within the constraints we have. So as a production engineer, especially when you are sitting in office, your job is to maximize the oil production, because more oil means more money. Okay, and whatever constraints you have, for example, you are limited with number of wells, maybe your separator design is not good, maybe you have pipelines, maybe the reservoir is producing asphaltene or wax, or maybe there are flow assurance problems. So whatever are the limitations you have, you want to maximize oil production, and you want to, whatever money you have invested, you want to bring the maximum out of it. Okay, so these constraints, limitations can occur in the reservoir in terms of, for example, as I say, flow assurance problem, asphaltene wax, and so on. Well issues, okay, gathering networks, maybe your pipelines are small, and maybe you don't have enough processing facilities, let's say for gas, or you cannot sell your LPG or so on because of the landlocked situation. Okay, so there will be incentive schemes, and field manager will award based on the optimum production that maximize the feed profitability within the constraint framework. So if you do well, perform well for the company, if you do good optimization, increase the company's revenue, definitely company will give you lots of incentives and so on. Okay. So now what should be in your mind when you talk about the maximizing production optimization? When we talk about the production optimization, well, first of all, you can impact the difficulties by rerouting wells. For example, you have one reservoir, you have three wells. So now, for example, this well is shut because of maybe you are doing some work or operation. So what you can do, you try to increase the production of them. So you maintain your production. Okay, so what we call rerouting the wells. Okay, and for example, this could be, you have to maintain the production level, or try not to close the well. Maybe the well is at 3 a.m. in morning, and so still at 3 a.m. in morning you have to go and start the well. Make sure that no well should be shut. Well should work 24 hours, 365 a day. That should be the. Now, for example, you have to minimize the production downtime. The other optimization you can do. This requires the effective surveillance and planning. I mean, effective monitoring of the production well. For example, you have to identify the problems and program a repair by providing operating baseline. So when these wells are operating, for example, you have the production wells, you have the wells, you have to monitor their production history. Okay, monitor production history. Keep track what is going on with the gas production, oil production, and water production. Is all the overall production is declining? Reason could be why. Maybe there should be a perforation issue. Maybe there could be a reservoir, some problem in the reservoir. Maybe some asphaltene is coming or blocking. So what could be the issue? Maybe some perforation is not. There is a formation damage inside the reservoir. So you have to monitor. Or on the other side, maybe the water production is increasing. So monitor whatever is the production history is coming every day. Every 12 hours you monitor it, and based on your monitoring, you keep looking at the production and try to find out what could be the problem coming in the coming time. So you have to identify those problems and then prepare a plan, repair program as soon as possible, so that your production should not decline and you keep producing as much as possible. And then other restrictions could be, okay, for example, if you have the gas production, you don't have good compressors. Maybe you want to produce more, but the pipelines are small. Maybe you cannot process them here. The refinery is not ready to take it, or well productivity is declining because maybe the tubing size is not good. So these could be the production restrictions helping. Maybe after some time the pressure declines, so you have to look at the lift gas allocation, the production rate setting and so on. So whatever the options you have, what is your objective is to maintain the production rate so that you can produce the maximum and minimize the downtime so that you can produce maximum from this production. Okay, when we talk about the optimization, follow four things. First of all, the PVT model. Okay, the composition, reservoir fluid composition. Then you have to do the system analysis. As in our case, we are going to do it using this IPM, Prosper and GAP software. You have to do the analysis, look at where pressure is dropping, design the gathering properly using the GAP software used to perform the calculation. Okay, and follow what are the limitations at gathering process level. As if what could be the problems that can happen: water coning or sand production, depletion. So when you talk about as a production engineer, you look at the PVT data. Okay, in simple words, you look at the PVT composition, PVT data, or crude oil composition. Okay, you have to look at the system analysis, pressure depletion, or reservoir issues. Could be sand production, or maybe asphaltene, wax production, or could be water coning or gas coning issue. So these are the issues possible that you have to monitor and look at them in the coming time. Make sure you have the correct field data, updated field data, because you can see IPR here is different, here is different. This is production rate versus time. As the time is increasing, the IPR is changing. IPR is changing, flowing well at pressure. So make sure you have up-to-date data, because data will change everything. So you have to monitor the performance every month at least to look at what's going on with the reservoir. Okay, and as a production engineer, you have to plan and schedule and forecast the production. Okay, you have to plan. For example, today is the month of, let's say, May. So in June, how many barrels of oil you are going to produce from this reservoir? You have this reservoir, uh, this is this reservoir. You have it here, and how much you are going to produce in the next month. Let's say in June 2020, how much production over? Maybe you have 10 wells in this one. Okay, you may have, let's say, you have 5 wells. 6 wells, let's say 1, 2, 3, 4, 5, 6. 1, 1, 2, 3, 4, 5, and 6 wells you have. But maybe one of the well maybe is not performing well, and 2 of them are not performing well. So you have to, when you plan your production, you need to know that how much you are expecting to produce from this month. So you, every month you have your forecast that this much oil you are going to produce from this well. So you prepare this kind of report every month. Okay, and you definitely re-optimization. If some well is not producing, you look at it, what is the problem, and then you prepare the job for it, give it to service company like Schlumberger, Weatherford, and sort it out with this one. Okay, then this is the activity that we have to look at. The as a production engineer, we look for the individual well performance, how the individual well performance is behaving, how the plants is behaving. Okay, what are the drilling conditions, and our production activities going on, drilling activities going on, and how much is the production forecast for this month. So every month we have this forecast. This forecast we do every month, but we look for the individual well performance every month. We look at the production facility constraints every month. What are the problem? Compressors are working, production is fine. Water problem they are handling, gas problems, gas production they are handling, and so on. So they follow all these activities at the same time. When they have to schedule and prepare the model and the software, and based on the software they do. Usually the IPM, Prosper, Gap, and these or these software are used for these production planning and forecasting and so on. And in the end, every month you prepare any well needs any repair, maybe completion, recompletion, maybe some stimulation job or so on. So we look for every month, we plan it, that what are the problems, and we look at the possible solution for them, and we plan those solutions, and so on. Then finally we have the environmental impact. Look at what you are doing with the water. If there's any oil spillage going on, what you are going to do with it. Okay, and look at the flare emissions. Follow the company plus government plus international standards of environmental impact assessments. And what are the possible physical disturbances there? What are the pipeline and discharges, and the flaring? So look at the potential environmental impact and follow them, so on. So that was the chapter 1, and I hope to see you in chapter 2, and we just started. And have a good day.